right, so we're looking at the rhombus and the rectangle today. The rhombus, something we should know is all the sides are equal. Rectangle, something we should know is all the angles are 90 degrees. So there are 5 things you should know about the parallelogram. So opposite sides are equal, right? Opposite sides are also what? Parallel. Opposite angles are congruent. Consecutive angles are supplementary. What do the diagonals do? Say by text. All right, all those 5 get passed down to these 2. These are also parallelograms, but more specifically, they have special properties that make them distinctly their specific shape. So from a parallelogram, it gets 5 properties. So it has 5 properties from a parallelogram. Number 6 is that all the sides are equal. So if it's a rhombus, automatically all the sides have to be the same. Number 7 says the diagonals are perpendicular. And number 8 states that the diagonals bisect a pair of opposite angles. So let me come down real quick to this one. The diagonals are perpendicular. Because they're perpendicular, what degrees are they making? 90. The moment you see that word, or the moment you see diagonals in a rhombus, automatically they're perpendicular, making that 90 degrees. And the 90 degrees is located here on your notes. So if that's 90, is the opposite angle from that also 90? Yeah, by vertical angles. What type of angles did I make inside the rhombus? What type of triangles did I make inside the rhombus? Right triangles. How many things do you know? How many formulas do you know about right triangles that in regards to the right triangles? 9. You know Pythagorean theorem. You know 45 45s. You should know 30 60s. You should know sine, cosine, tangent. And if you know sine, cosine, tangent, you'll also know inverse sine, inverse cosine, inverse tangent. 9 different things you can use in these triangles, okay? The next one is the one a lot of us were wanting to do on the parallelogram, and that's just that the angle's cut in half. So if this whole angle is 100, then these would both be 50. These would both be 40. Opposite angles are still the same, but the angles are now being cut in half, okay? So the diagonals are bisecting the opposite angles. All right, let's just focus on rhombuses, okay? So rhombis, there are 8 things you know about a rhombi, okay? How would I solve for x here? Given that this is a rhombus, and we're just going to set them up. We're only going to solve if we absolutely have to. How would you set up the formula to solve for x?
Subtract 180 from 104, and then figure out, and then set x equal to that.
Yeah. These 2 angles, mind you, this is a parallelogram. So consecutive angles are still supplementary. So we could do 104 plus x equals 180. That's one way to do it. How else can we solve for x? How else can we solve for x? How many degrees are in a quadrilateral? 360. Well, if I know all of it's 360, could I figure out these 2 angles or put something here to represent these angles? What would this angle be? Dane? What would this angle be? 104. What would that one be? X. So if you know this is 104 and this one's x, what could you do with all your angles? Add them all up and set it equal to 360. So you could do 104 plus 104 plus x should equal 360 degrees. All right, what about for y? For y, there's only one option. How would we solve for y? Just set them equal. All right, even if you didn't know that, if you didn't have these markings there, the fact that they're telling you it's a rhombus, all the sides should be the same. So for the y, it's just setting y plus 8 equal to 3y. All right, so for the x, you do have 2 options. It won't always be the case, but in some cases, you do have multiple options. All right. All right, let's look at this one. Let's just talk about it. So how would y'all solve for x on this one? How would we solve for x? Just equal them, right? Because parallelograms, what do we know about their angles? That if they are opposite, they should be what? They should be congruent. All right, what about the y's? How would I solve for y? Also set those equal. Those are sides, and their little markings are there for you. Y plus 3 should equal 2y plus 1. And again, if the markings weren't there, the fact that they're telling you it's a rhombus, you're allowed to add that to your diagram. Okay? All right, let's come down to this one. This one talks about diagonals in the rhombus. What's true about the diagonals in a rhombus? They do what to each other? They're perpendicular. What else? They bisect. What else do they do? They bisect angles. So this angle is split in half, and these are congruent, so these two are the same. And then this one's also split in half. That's just reading the first line. The fact that we have diagonals and a rhombus, all of that was given. So that's kind of how you want to approach the questions, right? They're talking about diagonals. What is it all I know about the diagonals? The question is, if FJH is 82, if FJ to H is 82, if this whole angle here is 82 degrees, find me the measurement from K, H to J. Find me that little one right there. So let me zoom in. All of this is 82. That whole angle is 82. They want to know that angle. How do we find it? What do we have to do? Why 41? Correct. So 82 divided by 2, because it's bisected, is 41. So he's getting 41 here and 41 here. So to get that x, he's saying, all right, so if I'm just looking for that, I know these two angles have to add up to what? What do they have to add up to? 90. They have to add up to 90. Or you could say that all three angles have to add up to what? 180. All right, so I'm going to do both options here. You could do option 1 that says 90 minus 41 equals x. Or you could do 41 plus x plus 90 equals 180. Both options are correct, right? One's looking at it as a whole triangle. Someone else is looking at it as the two acute angles in a right triangle. Either one's correct. Just pick one to do. All right, the next one's looking at sides. What do you know about the sides on a rhombus? They're all equal. So if you're looking at sides, you can go through and mark them equal and say, okay, if they're giving me J to H is this, and they're giving me, G to H, if G to H is x plus 9, and J to H is 5x minus 2, how would I solve for x given those two equations on the sides? Just set them equal. Just setting them equal. We don't need to solve it on our notes. You're going to get that opportunity on the homework, okay? So just set them up. That way you at least know what the process is, okay? All right, when you go ready, go over to the right side. See if you can do the one on the right side. So this one says the diagonals of a rhombus intersect at V given the information. Use the given information to find the measure or the value. So it says WBZ, this angle right here, is 2x plus 10. Well, there's nothing there. They didn't give you another angle. So how did y'all get 40? The diagonals are perpendicular. And if the diagonals are perpendicular, they make that 90 degrees. So this is just a matter of setting 2x plus 10 equal to 90. That's it. All right, next one says, if W to X is 15 and W to V is 12, how would you find the length of V to X? Pythagorean theorem. If this is 90, then the one next to it must also be what? 90 in order for that to equal that 180 relationship on the line. So that means I can use Pythagorean theorem to find this side. I can do a squared plus b squared equals c squared. Why does the 15 have to be the c? Who can tell me? Because it's across from the 90. So 12 squared plus x squared, those two can be interchanged. The 15 has to be isolated on the right side. Okay? 8 things you know about the rhombus now. Let's go on to the rectangle. I know you're so excited. See the excitement on everyone's face here. All right, how many things do we know about the parallelogram? How many did we say at the beginning? 5. 5 things you know about the parallelogram. All right, start memorizing them. All right, now if it's a four-sided shape, if we have the quadrilateral, it's only considered a rectangle if it has the following. If it has all four right angles, but then the diagonals are congruent. That's something we haven't seen yet. The diagonals are congruent. That means the diagonals are still bisected, right? Because that's a property from the parallelogram. But now they're all the same. So if this is 3, then this one's 3, and that one's 3, and that one's 3. That's the only difference. That if it's a rectangle, all these little pieces have to be the same. Okay? All right, so let's just use that. It says the Texas Park and Wildlife Organization plans to add 2 diagonal walking paths as shown to one of its parks. P to S is 180. P to S is 180 meters. It says P to R is 200 meters. What's the length from Q to T? They just want to know this little piece right there. How do I find that piece? What do we know about the diagonals? What do we say up at the top? That they're what to each other? Congruent. So that means if P to R is 200, what's the length of P to S? P to S is 100? P to S. Q to S. I meant to say Q to S. Q to S is what? 200. So then to find Q to T, what would I do? Just split in half. So 200 divided by 2 would give us 100, and that would be for Q to T. Okay. I promise if you get your properties down, this test should not be difficult. Okay. It says the quadrilateral JKLM is a rectangle. So they're already telling you what it is. It's saying here's a rectangle. If K, J to L, if this angle here is 2x plus 4, and JL to K is 7x plus 5, that's this one here, find x. Okay, I didn't put the angles there because I just want to talk about the angles. I didn't put the expressions on it. Does anyone know what they're going to equal? Why 90? But not this one, because this angle is here. And the other angle is here. What is that, David? There's 4 right angles. Okay, let me draw the right angles on here. There's a right angle, there's a right angle, there's a right angle, and there's a right angle. But why should they add up to 90? Because right now they're far apart. I don't see the relationship of it being 90. You're right. I'm just trying to get you to explain it to your classmates. What is it? Not consecutive. Because it makes a triangle? Okay, that's one reason. I can take that one. Someone may look at it as this triangle, right? And they may say, all right, the 2 acute angles always have to be 90, right? So this one plus this one equals 90. Or all 3 of them have to equal 180. What's the other one, Alexis? They're parallel. So if whatever this one is, the one alternate interior angle to it must also be congruent. So then they're both sitting on that 90. Both explanations are correct, right? So you can look at it as a big triangle overall, right? A rectangle cut directly in half by a diagonal. Or you can move it and then find that relationship there. Okay, I want to talk about this picture real quick. What do we know about the diagonals in the rectangle? Oh, so on this one, sorry, let me let you finish off your notes here. Let's go ahead and write this out before I get into my explanation. That one plus that one should equal 90. Okay, that's all you do. What do we know about the diagonals in the rectangle? They're congruent, right? What else are they doing to each other? Bisecting, right? So this is cut in half, but they're congruent, so these have to be marked the same. All right, what do we know about the opposite sides on a rectangle? Opposite sides. Yeah, the top one has to be equal to the bottom. The left has to be equal to the right. Okay. I want y'all to look at the triangles inside and tell me, what do you notice? Several things you can notice. What do y'all notice, though? It's isosceles. We have isosceles triangles. What else? You're right. Why are you saying side, side, side? All the sides are equal? Okay, so if I focus on this triangle, and that has side, 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 what is that going to tell me? You know, you're on the right track, Dom. Who can help him? If this is side, 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 what is that telling me? That this triangle what do you think, Alex? Not all angles are 60. No, 45, 45. Which one is marked identical to this one? What triangle? Opposite going like up, down, or directly across? Directly across. Okay. Do y'all see these two triangles are marked exactly the same?
Yeah.
Right? This has a marking of 1, 1, 3. This has a marking of 1, 1, 3. They're congruent by side, side, side. That means whatever this angle may be, whatever this angle is, I know this one's identical to it, right? Because you can almost flip it over, and they should overlap. If you imagine flipping this one onto this one, they should overlap perfectly. Now, someone did say, was isosceles. So if this angle is, I don't know, is 90, is 70, what should this angle be? So then these two angles are always the same. Is that true with the one on top and the one on bottom, those triangles? Yes. So these two are always the same, and these two are always congruent to those. Just something to show you guys. Y'all may see that relationship in other shapes. Those are justifications. You're giving me reasons, right? They were the same by side, side, side. Because they're isosceles, opposite angles have to be the same. Though you're giving me definitions. You're proving to me why they have to be the same. Sorry, I didn't know if I had anything left on this side. Okay, so let's look at it on this one, right? It says, I want to find F to H. What would the length of F to H be? How long would this be?
23.
Why 23? You got it.
Because all the things are equal.
All the diagonals bisected and all the pieces are equal? Okay, so I get that one's 11.5. But why is the other one 11? Why is the other one 23? Like if that one adds up to 23, why is F to H 23? Because what do you know about the diagonals in a rectangle? Diagonals are congruent. All right. What about angle J, G to H? How would I find that angle? Just that one right there. Right there. How would I find that angle? Angle X. Go ahead, David. Perfect. What do we know about all the angles in the triangle? All the angles in a rectangle? All angles are 90 degrees, or they're all right angles? Right, that was one of the properties we saw. Okay, take the idea of the triangle, okay? All right, I want you to try this one on the back side. So I'm going to do it with you. All right, so we're going to draw a rectangle. So draw me a rectangle. Pick any corner. I always start on this corner. I don't know why, but I do. Now, when you label it, just like we did yesterday, you go around. R, S, T, U. Always clockwise, okay? It says if the measurement of RTU, so I'm going to trace that, RT to U. They're talking about this angle. If that angle is 8x plus 4, and S, U to R, this one here, is 3x minus 2. How do we find x? Let's see if y'all are paying attention. I know some of you guys were fighting. You guys are fighting the urge to fall asleep. How would I find that x? What would we do? Do what now? But they're not even next to each other. So how are we going to equal them to 90? Well, yeah, all the angles are 90, but why those two? I don't know if they should add up to 90 together. The what now? The acute triangle thing? So what did we say about these two triangles? That they're what type of triangles? Isosceles. And we said whatever this one is, this one has to be the same thing. So now are those two angles next to each other? Yes. And do they make up the 90 degrees? Yes. So it is adding them equal, or setting them equal, adding them and setting them equal to 90. All right. How would we solve for x on this one? Do we add them? Just equal them? Just equal them. All right, so 7x minus 2 equals 5x plus 16. What's your x value? 9? All right, so if x is 9, what's your length from B all the way to M? What would we have to do? We'd have to plug in 9 where? Into one of them, right? Does it matter which one? No. Okay. So that's 45 plus 16. What's 45 plus 16? 61. So that means these are all 61. So how would I find the length from B all the way to M? What would I have to do with the 61 now? Times 2. This would be your final answer. And then the last one is find the measurement of O, M, to B. How would I find this angle? Correct. Subtract 36 from 90. These are alternating interior angles, these two here. And then again, every angle on a rectangle must be 90 degrees. And then that'll give you your angle. All right. So much fun, right? Who thought we could have so much to talk about with these quadrilaterals? All right, Alexis wanted me to bring this back, so I told her I would. So, Alexis, what's your first reason? First reason's always given. I'm just kidding. She didn't ask. Nobody get after her. All right. I gave you it's a parallelogram. Did I give you anything else? Nothing else? It's isosceles. The triangle JKL is isosceles. The definition of isosceles, what does it mean to be an isosceles triangle? What's equal in the isosceles triangle? The two sides. Okay, now that one did say it was triangle JKL. So JKL is this one. What two sides would be equal? K to J and K to L. Okay, so K to J must be equal to K to L. Now the next one is saying that K to L and J to M are equal. Why are they saying those two are equal? Properties of a parallelogram. What is that property of the parallelogram? That opposite sides must be what? Congruent. Good. So both pairs, or you can just put opposite sides, are congruent. Mind you, on the test it'll be multiple choice, so just pick the one that goes with it. All right, then definition of congruence. So I want you to look ahead. They want you to use the definition of congruence. Does anybody remember what that does to our statements? It just goes from equals to congruence, congruence to equals. It just makes the sign change. That's all it does, okay? Does anybody remember what the transitive property is? Yeah, so remember, I give my money to Ethan. Ethan gives it to Alexis. So technically we take Ethan out, so I gave my money to Alexis. 3, take out the middle guy, right? A to B, B to C. So A to C is really what happens, is what's happening. So the definition of congruence, the only thing that is not congruent here is that one. And the reason I'm going to change that one is because to use the transitive, they all need to be in this, they all need to have the same symbol. Okay, so I'm just going to change this one to have a congruent symbol. Definition of congruence. So on your test, if you think it's definition of congruence, the only thing changing is the symbol, okay? Now the transitive. They want to prove that this is a rhombus. If this is truly a rhombus, then what has to be true about it? All the sides have to be equal. That's where we're going to, okay? That's what the goal is. They want to use the transitive property because we already know those two are equal. Now they want to show these two are equal, okay? And they also want to show these two are equal. So what I want you to do is focus on these two first. What do they have in common? Okay, if I take K to L away, out of both of them, what's left? J to M and K to J. J to M, which is this one, and K to J, which is this one. So they're proving that these two have to be the same now. All right, so now go to the next two. Now try these two, because I have to make a connection with them. So what do they have that's the same? J to K. So if I take J to K out, what's the only thing left? L to M and K to L. And of course, these could be written in reverse order. That's fine. All right, so that's showing that all the sides are the same. So this is a rhombus because all sides are what to each other? Congruent. Okay. For the test, I would recommend just studying the proofs on the notes. Okay, just be kind of comfortable with them on why we put that reason.